Okay, so this is section 1.2. You should also read the book. Section 1.2 and 1.3 goes over linear models and linear equations and some of the basics I'll review right here. Remember the slope-intercept form of an equation. A linear equation is y equals mx plus b. So I have here an example, y equals 2x plus 1. So if I graph this, the number in front of the x is the slope. So the slope is 2. And remember, slope is rise over run. And the number after that, the term constant here, the 1 here, is the y-intercept. So we have a slope of 2 over 1, and we have a y-intercept of 0, 1 for this equation. And so to graph that, you go up on the y-axis and put a point at 0, 1. You do that first. And then the slope is 2 over 1, so you could rise 2 units and then go to the right 1 unit. Or you could go down 2 units and go to the left 1 unit. So this is the line y equals 2x plus 1. The slope of a linear equation, that's a constant rate of change. That means for every increase in 2 units, you are increasing 1 x unit. And that stays the same throughout the line. Okay, so how do we find the slope? Well, if you're given 2 points, x1, y1, and x2, y2, then you can calculate the slope by finding the difference between the y coordinates over the difference between the x coordinates. So for example, if we have the point 3,7 and the point 715, the slope would be 15 minus 7. If you lead with the y coordinate from the second order pair, you would just lead from the x coordinate from the second order pair. So you'd have 15 minus 7 over 7 minus 3. Remember, this is a grouping symbol. So 15 minus 7 is 8, and 7 minus 3 is 4, and 8 divided by 4 is 2. So the slope is the change in y over the change in x, and that's a constant rate of change if you have a linear equation. Even if the equation is not a line, you can find the average rate of change, or the arc. And the formula is the same. It's the change in the y's over the change in the x's. So it's y2 minus y1 over x2 minus x1. And this is just function notation. F of x2 is the same as the y coordinate minus f of x1. That's the same as the y coordinate. So now in Excel, what it's going to look like is if you have a column A and you're labeling column A x and column B you're labeling f of x, this could be like your x1, and that would be your x2, and this would be your y1, and this would be your y2. So this is B3 minus B2. So this is y2 minus y1. And I've mentioned this in another video. Excel doesn't do a horizontal grouping symbol. It only does a sideways division symbol. And so that's why these parentheses here are extremely necessary. So you have parentheses B3 minus B2, close the parentheses. That tells Excel to subtract the 2 first, divided by parentheses A3 minus A2. And you use parentheses, and that tells Excel to subtract them first. And then once you have the difference here and the difference here, you divide. So the formula in Excel for average rate of change is very important. Well, what does the slope tell you? It tells you how fast the graph is changing in the direction of change. So what that means is if you have a large positive number, then you could say that that as x increases by 1 unit, your y's are increasing by 15 units. And if your arc is negative, then you would say as x increases 1 unit, your y's are decreasing by 3 units. Okay, so the next thing in section 1.2, we go over cost, revenue, and profit. First, a cost function is made up of a variable cost plus a fixed cost. And fixed costs are like rent you pay for a warehouse, or electricity, or startup cost for materials. Those are fixed costs. And then your variable costs are things like, maybe it costs $1.80 to make one item. So for every item you make, it costs you $1.80. So for example, C of x equals 1.8x plus 20. That 20 is your fixed cost. And this 1.8x is your variable cost. And this is important for Excel because if it says variable cost, it's the entire term. But the marginal cost is just the number in front, or the slope. So the marginal cost is 1.8. So variable costs are the cost to produce X items. Marginal cost is the cost per item. So if I ask for the variable cost for 3 items, you would do 1.8 times 3 and get the cost to produce 3 items. But this 1.8 is for every 1 increase in item, your cost is increasing by $1.80. So this is your marginal cost. Fixed costs, again, we've said they're costs that are incurred every month that do not change, such as rent, utilities, telephone, computer, etc. Okay, so revenue is the selling price times the number of items sold. So if you sell one item and you're selling it for $2, then your revenue is $2. If you sell 2 items and your selling price is $2, then your revenue is $4. So it's just a very simple formula. Revenue is the price you sell the item for times the number of items sold. Now, just for future reference, the selling price is either going to be given to you, or you have to use something called the demand equation. And so I'll go over that in just a little bit. But for now, here's our example. If I sell sunglasses for $12 each, and the cost function is C of x equals 1.8x plus 20, what would be a good revenue function? Well, revenue is the selling price, which we know is 12, times the number of items sold, which we don't know. So we're going to let it be represented by x. Now, why x? Well, if we peek ahead, the cost function C of x, this x stands for the number of items. And if we know the number of items, we know the cost. So since we've got x here, we're going to let x be the number of items. So our revenue function would be price that you're selling it for, 12, times the number of sunglasses. So that's your revenue function. The profit function is going to be built by us, and it is the revenue, or the money that you make, minus the cost, the amount of money that you have to lose in order to get your items sold. So profit is revenue minus cost. So what would be my profit function? Well, profit function, if we use function notation, x is number of items sold, and it's revenue, and we have a revenue function, 12x, minus the cost. Now, notice that the cost function is 2 terms, so this is very important. You have to remember to put parentheses around the cost function, because this negative needs to get distributed. So P of x is equal to 12x minus 1.8x minus 20. So our profit function would be 10.2x minus 20. This minus 20 makes sense because that's our fixed costs, and that's going to take away from our profit. Okay, the next thing that we want to go over the definition. What does it mean to break even? So if we want to find out when we will break even, that's when the profit is equal to 0. So if we can take this profit function, 10.2x minus 20, and set it equal to 0, we get 10.2x is equal to 20, and divide by 10.2, and get x is 1.96 items. Now you can't have 96 hundredths of an item, so you would have to go up and sell, all right, 2 items in order to break even. Okay, so I alluded to the demand equation, and so the price of an item, we could use any variable, but usually we use P for price, and the number of items, we just use X, but a lot of times we'll use Q for quantity, so the number or quantity of items is usually Q. A demand function is the demand of a product as a function of the price. And the demand is from the consumer's point of view. A reasonable demand function is linear and it has a negative slope. Well, let me explain why it's going to have a negative slope. So look right here. This is a demand equation. P stands for price. Q stands for number of items. And this says that the number of items is equal to -2 times the price plus 20. So this is a negative slope. And so as the price goes up, your number of items is going to go down, which makes sense because if you think about demand is the consumer's point of view, as the price of an object, an item goes up, then less people want to go buy it. As the price goes down, then more people say, hey, I can afford this now, and they go buy it. So that's why your demand function usually has a negative slope. This P stands for price, this Q stands for quantity. Pretty straightforward, but oftentimes you'll see this very same equation in function notation, and that gets a little bit harder. We really have to understand function notation. So we can see that since P is in the parentheses, this is our independent variable. And this D stands for demand, but really what this D of P is, it's Q. So this is saying that when we know the price of an item, then we know the quantity of the item, and it's called the demand, quantity of demand. And the reason that the D is there is because there's something else called a supply function. So a supply equation gives the number of items supplied as a function of price as well. And the supply function is from the producer's point of view. And usually supply equations are nonlinear and they have an increasing slope. So for example, Q equals P squared plus 5 would be a supply equation. I would tell you that. You don't know that by looking at it. But that's why function notation is so helpful, see, because if you write it in function notation, you know your independent variable is still price, just like the demand equation. This is still Q. This whole thing is still Q. So if we know the price, we know the quantity. But in function notation, if we use the letter S, we name this function the supply, the quantity of supply, when we know P. So this is function notation for the supply equation. And so the question here, what happens is the price increases. Well, this is from the producer's point of view. So as the price increases, the producer is going to want to produce more items. So they're two different equations, but they're both in terms of P and Q. Okay, so what do we do with this demand equation and the supply equation? Well, we can find something called market equilibrium. So the market equilibrium is where the demand and the supply meet, where they're equal. It's the price where the consumer is happy because the price isn't too high and the consumer is going to go buy things, and the producer is happy because the selling price is high enough where they're making a profit that they're happy with. So the market equilibrium occurs where the demand and the supply meet. So if I have demand equation, don't want to get what it is, negative 2p plus 20, and the supply equation, which is p squared plus 5, I can find the market equilibrium by setting these two equal to each other. So this, remember, this is Q and this is Q. So they are not different variables. They are both quantity of items, and that's quantity of items. This is demand equation, this is supply equation. So if I want to find the market equilibrium, I can set the two equal to each other. And so this is a quadratic equation, so we can set it equal to 0. And I can move this negative 2p over to this side. So that'd be positive 2p. And I can move this 20 from the left side to the right side. So that would combine with the 5 and make a negative 15. And then this factors into p plus 5 and p minus 3, and that equals 0. So then I can set p plus 5 equals 0 and p minus 3 equals 0. And so p is negative 5 or p is 3. Now p stands for price, so we wouldn't want to sell it for a negative price. So the market equilibrium occurs when the price is set at $3. And then if I want to find out the quantity, I would simply plug 3 in, and that's going to give me 9 plus 5 is 14. And if I plug 3 in here, I get 14 items as well. So this is indeed the market equilibrium. So the market equilibrium is $3 and 14 items sold. So notice how I found the market equilibrium. It wasn't just the price that I gave. I want you to give me both parts. $3 and 14 items sold is the market equilibrium.